Hi again, Captain Peter Cutsie with another online briefing. Today we're going to discuss wind shear, both reactive and predictive. So the objective really is to recognize indications of wind shear and know the proper wind shear recovery. Wind shear encounters near the ground are the most threatening because there is very little time or altitude to respond to and recover from an encounter. The wind component is mostly horizontal below 500 feet. Horizontal wind shear may improve or degrade vertical flight path performance. Wind shear that improves performance is first indicated on the flight deck by an increasing airspeed. But this type of wind shear may be a precursor to a shear that decreases airspeed and degrades vertical flight path performance. Airspeed decreases if tailwind increases faster than the aircraft is accelerating. Airspeed decreases if headwind decreases faster than the aircraft is accelerating. If the airspeed decreases, the aircraft normally tends to pitch down to maintain or regain in-trim speed. The magnitude of pitch change is a function of the encountered airspeed change. If the pilot attempts to regain lost airspeed by lowering the nose, the combination of decreasing airspeed and decreasing pitch attitude produces a high rate of descent. So you have to watch that. Ways to recognize. The following are indications that the airplane is in wind shear. Wind shear warning, two-tone siren, followed by wind shear, wind shear, wind shear, and also an indication on the PFD, or an unacceptable flight path deviation. Unacceptable flight path deviations are recognized as uncontrolled changes from normal steady state flight conditions below 1,000 feet above ground level, in excess of any of the following: a 15-knot indicated airspeed change, more than a 500 feet per minute vertical speed change, more than a 5 degrees of pitch change, more than 1 dot displacement from the glide slope, or an unusual thrust lever position for a significant period of time. I have found through my experience in flying and also observing in the simulator that very often you will not get the wind shear warning. You will get the 15-knot change of speed prior to that, and your reaction should be on these indications if you should get them. What I'm saying is you don't wait for the wind shear, wind shear, wind shear. If you are observing what I've highlighted here, then you complete the wind shear escape maneuver by calling wind shear, which means to the pilot monitoring that you are going to conduct the wind shear escape maneuver. We'll discuss that in a few minutes. Okay. So considerations. Anytime you are flying, you should always be aware of weather changes, etc. So weather forecasts, the ATIS information you're receiving, which you normally pick up 200 miles out on VHF, or if you have a printer, you can get it before. thunderstorms, predictive wind shear, aircraft radar, and avoidance techniques. These are all considerations anytime you go flying. Now let's have a look at the wind shear during takeoff. Predictive wind shear is what we're talking about, and you will get a monitor radar display oral. So pilot flying maneuver as needed to avoid the wind shear. So a warning, predictive wind shear ahead, or a warning before V1, reject. After V1, perform the wind shear escape maneuver, which we will discuss. If wind shear encountered during the takeoff roll before V1, there may not be sufficient runway remaining to stop if an RTO is initiated at V1. At VR, rotate at a normal rate towards 15-degree pitch attitude. Once airborne, perform the wind shear escape maneuver. If wind shear is encountered near the normal rotation speed and airspeed suddenly decreases, there may not be sufficient runway left to accelerate back to the normal takeoff speed. If there is insufficient runway remaining to stop, initiate a normal rotation at least 2,000 feet before the end of the runway. You have runway markings, so you know when you're 2,000 feet remaining. Even if the airspeed is low, higher than normal attitudes may be needed to lift off in the remaining runway. Ensure maximum thrust is set. Now, predictive wind shear during the approach will be announced by an oral go around wind shear ahead. So perform the wind shear escape maneuver by calling wind shear and then carry out the maneuver. And we'll look at that in a second. Or at the pilot's discretion, perform a normal go-around. Now you have to be very careful. Don't get the procedures mixed. A go-around and a go-around procedure and a wind shear escape maneuver or procedure are different. The go-around, you're calling for a change in flight controls in gear and flap. So you don't want to do that. The wind shear escape maneuver, you do not change any configurations. So be very careful. So your instructor will actually teach you and emphasize that if you're going to recover from wind shear, announce wind shear and carry out the wind shear escape maneuver and not the go-around procedure. So this perform a normal go-around is in the QRH, but beware of it and use your head. Wind shear encountered in flight, perform the wind shear escape maneuver. Key techniques. In critical low altitude situations, trade airspeed for altitude if possible. An increase in pitch attitude, even though airspeed may be decreasing, increases the lifting forces and, in fact, improves the flight path angle. That's your PLI. So pitch up to the PLI as required. The command bars will give you wind shear guidance. And they will also be giving you wind shear guidance if your rate of climb drops below 600 feet per minute. If for whatever reason, if your rate of climb decreases below 600 feet a minute and the command bars are not giving you the proper information, make sure you pitch up to 15 degrees or the PLI. But basically, you should be following your command bars. Avoid large thrust reductions or trim changes. Cross-check flight director commands using vertical flight path displays. Your IVSI is one of your best tools. Pilot monitoring to call out any deviation from normal. So those factors are very important. Wind shear escape maneuver. Severe wind shear may exceed the performance capability of the AFDS. Pilot flying must be prepared to disengage the autopilot and disconnect the auto throttle. Do not change gear or flap config until wind shear is no longer a factor. Monitor vertical speed and altitude, and do not try to regain airspeed until wind shear is no longer a factor. Disconnect the autopilot. Press either toga switch. Aggressively apply maximum thrust. Disconnect auto throttle after maximum thrust. Simultaneously roll wings level and rotate towards 15 degrees. Retract speed brakes and follow the flight director. And if needed, pitch up to the PLI. So that is the wind shear escape maneuver. And pilot flying, when you initiate it, you announce wind shear, wind shear. That means you are going to conduct this procedure. Let's have a look at the QRH. And it's just what we discussed before during takeoff roll, wind shear ahead on oral. And if it happens before V1, you'll reject. After V1, you'll perform the wind shear escape maneuver. So as we mentioned before, and this is right from the QRH, exactly what we had discussed before. And we're just reviewing it now with the QRH. So know your QRH or know your manuals. And remember, predictive wind shear warning during approach. Go around wind shear ahead as the oral you'll hear perform the wind shear escape maneuver. But that would be my preference, as we mentioned before, rather than the normal go around, because they're two separate maneuvers. Remember, in the wind shear escape maneuver, you do not change configuration. So if you conduct the wind shear escape maneuver once you're out of wind shear, then you call for and initiate go around. Set go around thrust. Make sure that N1 probe is enunciated, pitching up to 15 degrees and ensuring the thrust is set properly. Then call flaps 15. And then the pilot monitoring on observing a positive rate will call positive rate. The pilot flying on hearing a positive rate will confirm the positive rate and call gear up. And then at 1,000 feet, bug up, clean up, and apply thrust as required. Remember, again, we've discussed this before, this is a review. Unacceptable flight path deviations are recognized as uncontrolled changes in normal steady state flight conditions. Below 1,000 feet, in excess of the following: 15 knots, 500 feet per minute, 5 degrees of pitch attitude, 1 dot displacement from the glide slope, or an unusual thrust lever position for a significant period of time. Those are all indications that you have a wind shear. All right, that's it for wind shear. It's a fairly quick review, but please go to the QRH and remember what we have discussed. If you want to discuss that with me at any time, my contact information is on the screen. I will be happy to give you and your training partner an online real-time briefing where we can interact. As a flight instructor, I shouldn't be preaching. I should be actually speaking with you and getting this information from you after you've done your work and studying it, and it's very effective. And we can do that online, where I will be a facilitator. In any case, enjoy your flying, stay passionate, and contact me if you want. Thank you. Looking forward to seeing you in the next video.